Welcome everyone. Today's lesson is going to be about circumference, so please make a heading of that in your notes. You can also note down our learning intentions, and we're going to be revisiting them a bit later. Let's talk about some key terms to do with circles. The first thing we're going to look at is a line that goes from the center of the circle to the outside. This is known as a radius, and the plural of this is radii with two i's. I think it's pretty cute. And we're going to use lowercase r to represent the radius because we can't be bothered writing the whole word each time. Now, another line that we can look at is a line that goes from one side of the circle to the other, passing through the center. This is known as the diameter, and the letter that we're going to use to represent that is the letter D. The distance around the outside of the circle is known as the circumference, and we're going to use the capital letter C to represent that. There's a special relationship between the circumference and the diameter of a circle. What we're going to do is we're going to ask you to measure some circles. With those measurements, you want to measure the circumference, the diameter, and the circumference divided by the diameter. Hopefully, you notice a very special relationship happens when you do the circumference divided by diameter. When you actually do the circumference divided by the diameter, you probably noticed that you often got a number pretty close to about 3.14, maybe a little higher or a little lower. This is the first few digits of a really important number that I know some of you are familiar with already, but it's a new friend to a lot of you. And this number is known as pi. Now, this symbol we use to represent pi, and by the way, pi is just pi, not pie, although that would be delicious. This symbol is a Greek letter, and there's a few ways that people like to write pi. I'm going to just show a few variations now. Whoops, that one was a bit too squiggly. But I tend to like to write it this way, but you can decide what works nicest for you. We use Greek letters quite frequently in maths, so they're pretty handy to be able to use to represent things. So that means for any circle you experience in the world, if you measure the circumference and you divide it by the diameter, you are going to get pi. Now, some people incorrectly think that pi is equal to 3.14, but it's not. As we talked about a moment ago, that's just the first few digits of pi. Let's have a look at it on our calculator. Now, maybe you're looking at your calculator at the moment and you can see that we've got pi here, but clicking this button doesn't actually let us use this. Because it's in yellow, we need to hit Shift. You don't need to hold it down, just click it once and then press this button and we'll get pi. When we hit equals, you'll notice that we get 3.14159 and a few more digits than that. Pi doesn't stop there. Pi actually keeps going forever. This is something known as an irrational number. It's got digits that go on forever in a non-repeating pattern. So we can't write this as a nice simple fraction here. So your calculator has rounded this off to this number decimal places, but that's okay. It's still a nice number of decimal places we can use for our calculations. So we've found a really important relationship here. We found if we do the circumference divided by the diameter, we get pi. And we can rearrange this equation, multiplying both sides by d, to get c equals pi d. This is how we're going to find the circumference of circles if we're given the diameter. Now, you possibly remember from before that the diameter was also equal to 2r, 2 lots of the radius. Now, what we're not going to write now is we're not going to write c equals pi and then replacing d with 2r. The reason is our rules of algebra tell us that we want to write the number at the front. So instead of doing that, let's write it correctly. C equals 2 pi r. Let's highlight that one too. So this one is a really helpful way of finding the circumference if we're given the radius. Now really, you only need to remember one of these formulae, provided you remember that the diameter is twice of the radius. They both really do mean the same thing, but I'm going to be using both depending on what kind of circle we're given. Looking at this first worked example here, we want to find the circumference, and there's 3 steps you're going to have to follow with every single style of question that involves a formula in measurement, and it's FSAU. That stands for formula, substitute, answer, with units. This is how you correctly communicate all of your measurement questions. We've got a circle here, and we've got this is 9 centimeters. Do you think this is the radius or the diameter? It's the diameter, so you might find it useful to write d equals 9 centimeters. So we're going to start off by doing our equation or our formula. Because we've got a diameter, we're going to be using c equals pi d. Then we're going to do the substitution step. So the substitution step means we're going to put in pi and we're going to replace that invisible multiplied sign here to make it clear what we're doing. And the diameter, we're going to put in 9. Let's leave the centimeters till the end of the problem. We've reached the step where we're going to actually use our calculator here. So we're going to do shift and get pi times 9. And the question actually asked us to round this to 2 decimal places. So when we look at this, that's going to be 28.27 to 2 decimal places. Now, we've nearly finished this question, and you might be tempted to start looking at this one now, but we haven't done the last step, which is putting units into our question. Because this is a length, and we've been dealing with centimeters, it's just centimeters. So this had all of the things that we needed. We had the formula step here. We had the substitution step after it. We had our lovely answer here, and our all-important units that some people tend to forget at the end. That's how you get full marks for this question every time. Okay, we now have a circle that has 3 meters written on here. Hopefully you recognize that that means the radius is equal to 3 meters. Let's go ahead and do our formula substitute answer with units. So our formula, c equals, which one do you think would be useful? C equals pi d or c equals 2 pi r? Let's use c equals 2 pi r here because we've been given a radius. So let's do the substitute step. We put back in those invisible multiplied signs, 2 times pi times our radius of 3, and then we're going to get our calculator. So we're going to do 2 times pi times 3, and we get 18.849555. If we round this to 2 decimal places, that's going to be 18.85. And what units do we need here? Well, it's meters. Okay, pause for a moment and write down this example. This example is asking us to find the circumference of a circle whose diameter is 14 centimeters. So we haven't been given a diagram here, but we know d equals 14 centimeters. So we're probably thinking we're going to be using circumference equals pi d for this equation. It's good to be thinking about what the question is going to ask you. I sometimes like to actually highlight that it's asking me for the circumference because later on we're going to be doing the area of circles. So we need to be clear what is the actual thing we're calculating here. So this question's a little bit different. It first asks us to give our answer in terms of pi. So that means we're not going to pick up our calculator and evaluate pi. It's going to remain in our final answer. It at first may seem a little bit tricky, but it's actually a little bit easier because we don't need to type anything into the calculator and you can do these questions really quickly. So we're going to, like we said before, do circumference equals pi d. And we found that it's going to be pi times the diameter of 14. Now I want you to think just, off the side here. You don't need to write what I'm writing in pink. If I gave you x times 4 in the past, you wouldn't have written that as your final answer. You would have written that as 4x because the rules of algebra tell us we write numbers at the start, and when two things are right next to each other like this, we have an invisible multiplied sign. We can do a very similar thing here with pi. So instead of writing pi times 14, we can just write 14 pi. So that's our answer here in terms of pi. We still have pi present in our answer here, which is just fine because the question wanted it. So we've done our formula step, our substitute step, and our answer step. We just need units on our answer here. So what units did we use in this question? It was centimeters. So 14 pi centimeters is the answer for this question. Part B asks us to find this answer to the nearest whole number. So the circumference equals 14 pi. That just means we're going to type 14 pi onto our calculator. We could write 14 times pi, but your calculator knows when you've got a number and then something right next to it, that means times. It doesn't really like it if you wrote pi 14. So 14 pi, and we're going to write equals, and we need to round that to the nearest whole number. So that's going to be 44, because that 9 is going to make us round up. So 44, and our units, centimeters. Excellent. So we have explored how to find the circumference of whole entire circles. There were two things we used for it. We either use c equals pi d, or we use c equals 2 pi r. We use the first one if we got given a diameter, and we use the second one if we got given a radius. Before we move on to the next bit, we just need to make sure we know what to call these portions of circles here. Now, the first thing we have here, we could call it a half of a circle, but I think a little more elegant of a way of calling it would be a semicircle. That just means half a circle. If we have a quarter of a circle, the most concise way of saying that is actually a quadrant. And hopefully you recognize quad makes you think of 4. There are 4 quadrants in a circle. I know for sure this is a quadrant because it has a 90-degree angle here. And I know a full revolution has 360 degrees. Oops, 360 degrees. And 360 divided by 90 gives us 4. So that's really handy to know. Now, we have 2 other portions of circles here. And these are actually called sectors. So here we have a smaller sector, and here we have a much larger sector. Now, one thing I didn't mention before is the angles involved in this one. Here, the semicircle, this angle here would be 180 degrees. But in these 2 sectors here, we don't know what the angles are. I'm going to introduce you to another Greek letter here. If I had an angle here, instead of writing x for an unknown angle, we tend to like to use the letter theta, which is another Greek letter. Now, theta, you have 2 ways people draw it. Some people like to do a little bit of a swirl, and some people like to do it like that. So theta is the angle, the unknown angle. In our bigger sector here, this would be the angle, and this angle is theta. So they're portions of circles. If we were to find the perimeter of a portion of a circle, we need to do 2 parts. So let's look at this semicircle just for a moment. If I wanted to find the perimeter of this shape, there's really 2 sections to this shape. There's this outside curved portion, and this outside curved portion, when we have a portion of a total circle, this is known as an arc. It's a portion of a circle here. And then we have this flat portion here. Now this flat portion, we could call it the diameter, which would be correct, but I notice it's also 2 lots of the radius. So this distance here is 2 lots of the radius. Let's explore the other shapes we've got here. Here we have a quadrant, and I notice this arc, well, that's a quarter of a circle here. So that's the arc, and it's good to think about the fact that that's a quarter of the circle. And we also have, again, 2 lots of that radius, 2r. And I notice for these 2 sectors here, we have arcs on both. That's the curved portion of a circle. So these are arcs. And on both of these arcs, I notice we also have 2 radii again. Remember, radius is the distance from the center to the outside of the circle. So we have 2 r's. R and R is 2 r's. So, with all of these portions of circles here, if we wanted to find the perimeter, we're going to use capital P to represent the perimeter here. We had to do the arc plus 2 lots of the radius. Now, 2 lots of the radius isn't too bad. If you're told the radius is 3 centimeters, you'd say, oh, 2 times r, that means 2r, which is the diameter, would be 6 centimeters. But how are we going to calculate the length of the arc? Well, in order to do that, I'm going to write arc length, and that's just the curved portion. That is equal to the angle that you're interested in, the angle, and that's the angle in the sector. So for a semicircle, that would be 180 degrees. For a quadrant, that would be 90 degrees. And for our sectors, it'd be whatever angle was drawn inside of the sector here. So these angles represent a fraction of the total circle. Well, hopefully you remember that's 360 degrees. Now think about that. In our semicircle, this angle's 180 degrees. And if we did 180 divided by 360, we'd get a half. That makes sense. We've got half a circle. In a quadrant, we said it was 90 degrees. And if we put in this value theta, 90 divided by 360 would cancel down to a quarter. That makes sense. A quadrant was a quarter. So whatever our unknown angle is, we're going to substitute our value of theta. Oopsie. I'm just going to get rid of that. That was in the background. So theta over 360 tells us about the fraction of the circle that we've got. So to find the arc length, we need to multiply that fraction of a circle times the circumference here. Remembering that that circumference could be 2 pi r, which for these portions would be really handy because we've got a radius, 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 or if you had a semicircle, for example, you could use pi d. We tend to, for most of the time, because we've got radii, write this as 2 pi r. And some of you might notice, but you don't need to do this, that you could cancel down a 2 here and a 180 here to have theta over 180 times pi r. You don't need to do that though if you don't want to. The reason why I tend to like to just write it like this is I can remember theta over 360 represents the fraction of the circle that I'm dealing with, and 2 pi r is the circumference. So rather than having to remember new stuff, I'm just putting together two things that I knew before. So when you're doing perimeters involving circles, make sure you write P. If you have any circular bits, you're going to put circle parts. That might be an entire circumference C, or it might be a portion of the circumference, which is an arc, and you're going to add on any flat bits. If it's a semicircle, a quadrant, or a sector, those flat bits might just be 2 lots of the radius. But let's have a look at some of the questions. Okay, so let's find the perimeter of some of the following. We've got a semicircle with a diameter of 20 meters, and we want to find it to 1 decimal place. What you can do is you can carefully sketch a semicircle here. We're told that the diameter is 20 meters, and we want to find the perimeter. So because we're not just doing a circumference, we're going to start our working out with P equals. Now, I notice that we have an arc here, and we also have this diameter, remembering that the diameter is 2 lots of a radius. And if we wanted to be careful, we could write radius equals 10 meters here, just so we don't get confused later on. So an arc, we said in order to find an arc, we had to do theta over 360 times 2 pi r, or times pi d, because it was times the circumference here. Because we're given a diameter, let's do times pi d plus d. So that's our formula and our substitute step. So perimeter equals, what is the angle in our semicircle here? Hopefully you recognize that's 180. Now we know 180 over 360 will be a half. So you could just write that as a half pi d. Some people even like to write it as pi d over 2. So pi d over 2 plus d. So pi times the diameter of 20 over 2 plus 20. You could cancel down a little bit here if you wanted. You could do, that's going to be 10 on top here, and that's going to be 1. Or you can just type it exactly into the calculator as it appears. So let's do pi times 20 over 2, or you could have just written pi times 10 plus 20. And we're going to round that to 1 decimal place. So that will be 51.4 meters. Now we've got a quadrant. Let's draw that carefully. A quadrant is a quarter of a circle because we've got 90 degrees here. So the perimeter is going to be the arc plus 2 lots of the radius. The arc is this portion of the semicircle, but that's not the total perimeter, which is the total length outside the shape. We also need to add on the flat bits, which happen to be 2 lots of the radius here. So that's going to be our arc, which is, theta over 360. I know that this is 90 degrees, so I could say, oh, that's just pi d on 4. Or you could have written 90 over 360 times, instead of pi d, let's do 2 pi r actually, because we've got 2 radii here. So you could have done that 2 times 2 pi r here, and that would cancel down to the same thing. And we're going to do plus 2r here. You could cancel down this 2 with this 4, and when we actually get to the point of substituting, that would be pi times the radius was 4 millimeters, and that was on 2, plus 2 lots of the radius was 2 times 4. We've done the formula, we've done the substitute. Let's do our actual answer now. So pi times 4 over 2. We could have even cancelled that down a bit more, plus 2 times 4. And we want to round that to 3 decimal places, so 14.283. And our units for this are millimeters, because we're doing a perimeter, which is a length. Okay, now we have a couple of shapes that are involving portions of circles and different shapes put together. And remember, we want to find this should say perimeter. So the perimeter of the following shapes in terms of pi now, and then to 3 decimal places. So to find the perimeter, we need to know the total length outside of the shape. We know that we can do this arc using a formula, but we also need all of the flat bits. I notice there's a portion here where I don't yet know the length, and a portion here. Well, I see that this here is 6 centimeters, and if this is 11 centimeters, then that must mean that this length here has got to be 5 centimeters, because 5 plus 6 will give us 11. Now, if this is 6 centimeters, this is the radius of this little quadrant. So this radius down here has got to be the same. So this also needs to be 6 centimeters. If this is 6 and this is 11, it just happens that this also seems to be 5 centimeters. So now I think we're able to start actually finding the perimeter. The perimeter is going to be equal to the arc plus, we've got this 5 centimeters, I think I accidentally erased, 2 lots of that 5, 2 lots of this 11 centimeters. So that's going to be 2 lots of 5 is 10, so you could do 2 times 5 plus 2 times 11. If you wanted to, you could do the arc separately, so arc length. It'd be good if I could spell length. That equals theta over 360 times 2 pi r, because we have radii here. Because that angle is 90 degrees, because I told you it is, that would be 90 over 360, which would be a quarter. So a quarter times 2 times pi times the radius of 6. When we put that into our calculator, we get a quarter, oops, that's a half, a quarter times 2 times pi times 6. I didn't bother cancelling anything off there because I know that I'm going to have to put this in 3 decimal places. But I nearly forgot what the question said. It said first find it in terms of pi. So I know this is going to be the answer to the first time in terms of pi, and the second one, we're going to do it to 3 decimal places. You don't need to write what I've written here. Maybe I'll put that in like a fun color like yellow, because that's just our thinking. That's nice. Okay, everything should be on the screen now. Now, everything here is multiplied, so we can actually cancel stuff off. So let's do 2 and 1. So we've got a half times pi times 6. I could also cancel off 1 here with this 6 here. So that becomes 1 over 1 times pi times 3. That makes our answer 3 pi centimeters in terms of pi. And now, I noticed I typed that into my calculator before. Provided my answer is correct, 3 pi should also equal 9.4247 ... Let's see. So we're going to do 3 pi. Excellent. That means I got the right answer. So to 3 decimal places, that's going to be 9.425. And our units are centimeters. I'd like you to have a go at the last example here, and I'm going to put the answer to see how you went.